very quickly. And here is the change. I think I said in my lecture notes that I'm going to discuss question 5, right? Question 5, subject guide question 5, that's what I said, right? I'm not going to discuss 5. 5 is pretty boring, standard. We'll discuss 6, okay? Discussing question 6. Here is the question. So there are two guys, Stephen and Robert, and they are risk neutral potential buyers of a Diggle hopper. I don't know what that means. But every buyer, so Stephen has his own valuation, Robert has his own valuation, and they know their valuations. The bidders don't know each other's valuation, neither does the seller, but everyone knows that bidders' valuations are drawn like this. Stephen's valuation is drawn from a distribution between 0 and 10. Robert's valuation is drawn from a distribution between 10 and 30. I'm told this. 10 and 30. Okay? Now you must be able to explain why I'm drawing it like this, why this is half. Right, so this is where Stephen is coming from, this is where Robert is coming from. Okay, the question asks you, this is an English auction, who will win in an English auction? The answer is, why? No one tells you in an English auction, that's the result, you have to prove it. There are two ways of doing it. You will say this, if the price is here, for example, the auctioneer has put a price here, there is a chance that Stephen might have dropped out of the auction or be still in the auction room, correct? If Stephen was here, then he would have dropped out of the auction. If Stephen is here, he would still be in the auction room. But Robert certainly will remain in the auction room at this price. If the price is here, Stephen might or might not be in the auction room, but Robert will certainly be in the auction room. English auction. You have a choice at any price between dropping out of the auction room or staying in the auction. Okay, those are your choices. At this price, again same idea, Stephen might or might not be in the auction room, Robert certainly will be. At this price, Stephen certainly won't be in the auction room, he will drop out. And Robert certainly will be in the auction room. Therefore, whatever else the case might be, the auction might not end here, or here, but it will certainly end here. Therefore, Robert will win the auction. That much is clear. Okay? Robert will win the auction. Okay, if Robert wins the auction, if at P is equal to 10, Stephen will certainly have dropped out, Robert wouldn't have, therefore Robert will win the auction, certainly. Next part of the question, what is the expected selling price? What is the expected selling price? What is the expected selling price? What price will Robert pay? Not necessarily, 10. If it doesn't follow that Stephen will drop out here, right? Stephen might have dropped out here, correct? If Stephen's valuation is here, Stephen would have dropped out before the end. Stephen's valuation is here, the auction would have ended here. This is what Robert would have paid. If Stephen's valuation is here, Stephen would have dropped out here. The auction would have ended here. Robert would have paid this. Correct? If Stephen's valuation is here, the auction would have ended here. Robert would have paid this. This will be the price only if Stephen's valuation is 10. Not necessary. I am not told that Stephen's valuation is 10. But whatever, so I don't know whatever Stephen's valuation is, that is the price Robert will pay. I know this much. Whatever Stephen's valuation is, the valuation of Stephen will be equal to the price that Robert will pay. If I knew the valuation of Stephen, I would have said, okay, that's the price. But I don't know the valuation of Stephen. When I don't know Stephen's valuation, what is my only recourse? To ask myself, on average, what is Stephen's valuation? On average, what is Stephen's valuation? Stephen is drawn from a uniform distribution between 0 and 10. Therefore, on average, what is Stephen's valuation? 1. Therefore, I don't know PR, I have to find expected PR, which is expected valuation of Stephen. which is 0 plus 10 over 2, which is 5. Okay? That's it. That's expected valuation. Okay? Now, just change the question slightly, tweak it slightly. Suppose I have told you this. There are two bidders between 0 and 10. Stephen and Marvin, two bidders, okay? Stephen and Marvin, two bidders. I don't know where they are. I just know they are drawn from this distribution. And here you have Robert between 10 and 30. Robert. English auction still. Who will win the auction? Still Robert. Still Robert. By the time the price reached here, you are guaranteed that Robert will be the only guy left in the room. Whether the price will reach here or not is another question. But guaranteed, Robert will be the last bidder, last remaining bidder in the room. Okay. Now I ask you the question again. What is the expected price that Robert will pay? Again, you know that whether Robert will pay the higher of whoever Stephen and Marvin are, whatever their valuation. If Marvin is the higher valuation, Robert will pay Marvin's price. If Stephen is the higher valuation, Robert will pay Stephen's price. That's where the auction will end. If you knew their valuations, I told you Stephen is 2, Marvin is 5, you know what price Robert will pay. Robert will pay 5. But now you don't know. You don't know. Therefore, when you don't know, you have whoever the highest guy is between Stephen and Marvin, you know that that's the price Robert will pay. You don't know who the highest guy is. Therefore, you must use the expected highest valuation between Stephen and Marvin, two bidders in this district. On average, where are Stephen and Marvin? On average, where are Stephen and Marvin in this district? This 0 to 10, two bidders break into three parts. Either Marvin or Stephen is here and the other chap is here. Either Stephen is here, Marvin is here, or Marvin is here, Stephen is here. I don't care who is here. But there is someone here on average. And therefore, Robert will pay that price, which is 6.6. That's the expected selling price. Okay. Next part of the question. Is this. Part B. Suppose the seller can impose a minimum bid level. Minimum bid level is the reservation price. The seller says, this is the price, you cannot bid anything lower than this price. Seller says. Okay? Cannot. You can bid higher, but nothing lower. I will not accept. Okay. We have the same distribution again. 0 to 10, 10 to 30. Stephen, Robert. Now the seller is deciding to impose a minimum bid level of 10 here. Nothing lower than this can be bid. Okay? Now, the question is, what is the seller's expected revenue? When I ask for revenue, you must first determine what are the equilibrium strategies of the bidder. Otherwise, you can't determine the outcome. Revenue means I am asking you for the outcome of an auction. Okay? So, this is the minimum bid level. What is Stephen's strategy? Will he participate in the auction to begin with? No, he will not even make a bid. He will drop out. He won't even come to this auction. He will not come. What is Robert's strategy? Will he come? Yes, he will. Yes, he will. His valuation is somewhere here. You know that he is willing to be in the room till the price reaches his valuation. Okay? He will come. So if Stephen doesn't come here, only Robert comes to the auction. Will the auction continue or will it stop? One bidder left in the auction room. Stop. And what price will Robert pay? 10. This is the next highest bid. When there is no other bidder, the minimum bid level is the next highest. Okay? The minimum bid level is the next highest. Okay. So the seller's expected revenue will be 10. Notice it increased from the previous case. Previous case, when there was no minimum bid level being imposed, the expected revenue of the seller was 5. Now it is 10. Now let us see what happens when the seller increases his minimum bid level to 15. This is 20, 15. No longer 10, 15. Again I am asking you what will be the expected revenue. What will be the expected revenue for the seller? Okay. When the minimum bid level is 15, revenue means It's an outcome. Outcome means first I must ask what strategies will the bidder use in equilibrium. Will Stephen come to the auction? Will Robert come to the auction? Depends. Depends. Robert is drawn between 10 and 30. If Robert valuation is here, will he come? No. If Robert's valuation is here, will he come? Yes. So if Robert's valuation is here, he won't come. What will be the seller's revenue then? Zero. If Robert's valuation is here, he will come. What will be the seller's revenue then? What is the expected revenue of the seller? Probability that Robert's valuation is here times 0 plus probability that Robert's valuation is here times 50. What is the probability that Robert's valuation is here? Very simple. Uniform distribution. Length of this line segment over length of this line segment. 15 minus 10, 5. 30 minus 10, 20. 5 over 20. 1/4. The probability that Robert's valuation is here is 1/4. In which case the seller's revenue is 0. The probability that Robert's valuation is here is 3/4. In which case the seller's revenue is 15. Therefore the expected revenue of the seller from setting this bid level is 11.2. I think. Yeah. Okay. 11. Again, increase. Increase. No bid level, his revenue was 5. With a bid level of 10, his revenue was 10. With a bid level of 15, his revenue is 11.25. So things like minimum bid levels are increasing the seller's revenue. Minimum reservation bids are increasing the seller's revenue. But clearly you should be able to see that this increase is not permanent. It will not happen all the time. You just have to ask yourself, what will happen if the seller imposes a minimum bid level of 30? In this case, what will be his revenue? 0. That means there must be some bid level here at which the seller's revenue is maximized. After which it will start dropping. After which it will start dropping. If I ask you what is this optimal F star, tell me how will you solve the problem first. I am asking you what is the optimal bid level for the seller. How will you solve it? No, you can, but Robert's average valuation is not going to determine what is the problem I am asking you? What is the value of F at which the seller's expected revenue is maximum? That's what I am asking you, right? Therefore, how will you solve the problem? You will get an expected revenue for the seller, that function, in terms of F, differentiate that function with respect to F, set it equal to 0, solve for F. Right? You are looking for the value of F that maximizes the expected revenue for the seller. There is only one way of doing it. Get the expected payoff function forward. Get the expected payoff revenue function for the seller in terms of F. So if this is F, ladies and gentlemen, this is F. Two possibilities. Robert might not come for the auction, in which case seller's revenue will be 0. Robert will come for the auction, in which case seller's revenue will be F. 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 Therefore, the expected payoff to the seller, revenue to the seller of setting a bid level of F, minimum bid level of F, is either he will get 0, which will happen with this probability. And what is the value of this probability? This distance over this distance, which is F minus 10 over 30 minus 10, 20, which is 0. Plus, Robert might be here. What is the probability of that happening? 30 minus F over 30 minus 20, 10, 20, in which case your revenue will be F. Cancels out. This is the expected revenue function of the seller as a function of F. What do you do now? Differentiate this with respect to F. In other words, differentiate this with respect to F. Set it equal to 0. Solve for F. I'm not going to solve it. You know how to do it. Okay. Questions? market. 10 seconds.